I am Sandeep, your new chemistry faculty. Today I will teach some basic concepts of chemistry. First, we will learn about what is chemistry. It is the study of matter, its structure, composition, and properties. So, chemistry is the study of matter, its structure, composition, and properties. What is matter? As you know, anything that occupies space and has mass is called matter. Anything that occupies space and has mass is called matter. What actually is made up of matter? So matter consists of atoms and molecules. Atoms and molecules. So we can say that chemistry is the study of atoms and molecules. So we can say that chemistry is the study of atoms and molecules. Atoms and molecules. Chemistry is a vast subject. It has many applications in our life, or we can say our life is incomplete without chemistry. So now we will look at the merits and demerits of chemistry. Merits and demerits of chemistry. First, we will look at the merits. Our basic necessity, or we can say basic necessities are food, clothes, shelter. For food, we need carbohydrates, proteins, lipids, etc. For clothes, we need cotton, nylon, polyester, etc. For shelter, we need home, and these are made from bricks, iron bars, cement, etc. We need furniture also, which consists of woods, iron, etc. So our basic necessities totally depends on chemistry. Food, clothes, shelter. Food consists of carbohydrates. Carbohydrates are the compounds of carbon, hydrogen, and oxygen. Carbohydrates are the compounds of carbon, hydrogen, and oxygen. Proteins also consist of carbon, hydrogen, oxygen, along with nitrogen, sulfur, etc. Lipids Lipids are also constituent of cell membranes. Cotton is actually cellulose. Cellulose is a polysaccharide C6H10O5 It is present in the cell wall also. Nylon, it is a polymer. So there are various varieties of nylon, nylon 66, nylon 6, nylon 2, nylon 6. Polyester, it is actually terylene, which is also a polymer. So these are used as clothes. Cell type. We have iron bars, iron, atomic number 26. It is one of the most stable element in the periodic table. Cement consists of so many silicates, calcium, etc. compounds. Furniture, wood consists of 90% cellulose and iron. So these are the basic necessity, food, clothes and shelter, which totally depends on chemistry. Now coming to, we need water, we need air. So water is this dihydrogen oxide. Air, nitrogen plus oxygen major trace amount, CO2, helium, etc. 21% nearly oxygen is there, 78.6% nitrogen is there. So we can say that major component of air is nitrogen and oxygen, which consists actually of 99%. Without air, we can't live. Without water, we can't live. Life originated in water itself. Next, we need medicines, we need drugs, we need many polymers. So, these are the substances, these are the compounds which help us live successfully in our life. So, what are medicines? Medicines and drugs, these are therapeutic agents. These are therapeutic agents. They help us cure so many diseases. Generally, drugs are addictive in nature. Medicines are not addictive in nature. Polymers, these are the combined state of monomers. They can be of two types, addition polymers or condensation polymers. Now moving to life-saving drugs. Life-saving drugs such as cisplatin, Taxol. Cisplatin and Taxol, these are anti-cancerous drugs. Drugs. They are used to cure some types of cancer. And one is AZT, azithromycin. This is used by AIDS patient. We know that there are various types of cancers, at least 200 different types of cancers are there. So these cisplatin, Taxol, these are the chemicals which actually kill cancerous cells. But they cannot cure all types of cancer. We know that cancer can be cured only in the initial stage, not in the final or terminal stage. AZT, azithromycin, it is used by AIDS patient to decrease the titer of the HIV virus present inside the body. Now moving to the demerits first. On the one side, chemistry is full of merits, but on the other side, it has some dark side also. Atom, hydrogen bomb, chlorofluorocarbons, explosives like TMB, TNT, nitroglycerin, citric acid. RDX, etc. So these explosives are very dangerous. They are used to make bombs. CFC chlorofluorocarbons. These are the culprit of ozone depletion. They release chlorine-free radical. They are highly inert, stable compound. This chlorine-free radical disturbs the ozone uh, layer, chlorofluorocarbons. They give chlorine-free radical which react with ozone to form oxygen plus fluorooxide-free radicals. So in place of ozone, there is oxygen. We know that ozone layer present in the stratosphere obstructs the ultraviolet light coming from the sun, or it acts as a shield. So this ozone layer is getting depleted by chlorofluorocarbons. So these are used as refrigerants. So nowadays these chemicals are banned. These chemicals are banned. Some other demerits are levisite, mustard gas, agent orange. These are the chemicals which was used during World War. Some agent orange was used during Vietnam War. It is a defoliant. So we are saying that on the one hand it has so many merits, but on the other hand it has so many demerits also. But we should use chemistry for the welfare of human beings, for the welfare of mankind. Now states of matter. There are 5 states of matter. Solid, liquid, gas, plasma, Bose-Einstein condensate. Bose-Einstein condensate. This is the 5th state of matter. Actually, so many research are still going on about Bose-Einstein condensate. Plasma is the 4th state of matter. 4th state. It is quite different from the blood plasma. It is quite different from the blood plasma. Solid means is rigid, where the liquid and gas can flow, so they are called fluid. It exists at very high temperature, whereas these exist at very low temperature, exist at sub-zero temperature. Present in suns or stars core. So there are 5 states of matter: solid, liquid, gas, plasma, Bose-Einstein condensate. Solid is rigid, particles are closely packed, very less diffusion, highly incompressible. Liquid, gas can flow, that's why they are called fluids. Plasma is the 4th state of matter. It exists at very high temperature, present in suns and stars core, where the temperature is 1.5 into 10 to the power 7 Kelvin, where nuclear fusion reaction occurs. Bose-Einstein condensate, it exists at sub-zero temperature. Here atoms behave abnormally. Atoms behave abnormally. Now moving to the next topic, that is mole concept. Moving to the next topic, mole concept. If we say 1 dozen, it means 12. If we say 1 gross, it means 12 dozens, that is 144. If we say 1 score, it means 20. If we say 1 mole, in a chemist workplace, it is 6.022 into 10 to the power 23 entities. These entities consist of electron, proton, neutron, atoms, ions, molecules, even biological viruses. Biological viruses. So, mole in chemist workplace means 6.022 into 10 to the power 23 entities or particles. This particle consists of electron, proton, neutron, atom, ions, molecule, even biological viruses. So, if we say 1 mole hydrogen, then it means 6.022 into 10 to the power 23 hydrogen atoms. 23 hydrogen atoms. If we say 1 mole electron, that means 6.022 into 10 to the power 23 electrons. 10 to the power 23 electrons. So this number is called Avogadro number. This number is called Avogadro number. This number is called Avogadro number. So 1 mole sodium is equal to 6.022 into 10 to the power 23 sodium atoms. So 1 mole chloride ion, that means 6.022 into 10 to the power 23 chloride. So anything which consists of 6.022 into 10 to the power 23 indices, that is called 1 mole. So 1 mole has as many particles as are presenting 12 gram of C12 isotope. So if you take 12 gram of C12, that means it is 1 mole. That means it is 6.022 into 10 to the power 23 carbon atoms. So this is the definition of mole. A mole consists of as many particles as are present in 12 gram of C12 isotope. As are presenting. So C12 is regarded as the standard of AMU. Standard of AMU, that is atomic mass unit. Atomic mass unit. Now coming how to calculate moles. So number of moles is equal to given mass by atomic mass. This is for atoms. Suppose 46 gram sodium is given and you need to calculate mole. So mole is given mass 46 divided by the atomic mass, that is 23 gram per mole. So it is 2 mole. So 46 gram sodium means 2 moles of sodium. We are taking the next example. 200 gram of H. So it is number of mole is 200 gram by 1. That is 200 moles. Now next formula is number of moles given mass by molecular mass. Molecular mass. These are for molecules. For molecules or compound. For molecules or compounds. One person. So 1 mole denotes Avogadro number of particles, that it consists of 6.022 into 10 to the power 23 entities. These entities can be electron, proton, neutron, atoms, ions, molecules, and even biological viruses. So now moving to calculation of moles for gases. Calculation of moles for gases. So number of moles equal to volume in liter by 22.4 liter per mole. Suppose 5.6 gram H2 at STP. STP is standard temperature and pressure. So number of mole is 5.6 liter of H2 at, so 5.6 liter by 22.4 liter per mole. So it is 1 by 4 mole, that is 0.25 mole. So 5.6 liter of hydrogen at STP has a mole equal to 0.25, that means 1 by 4 mole. Because any gas, irrespective of its nature, has a volume of 22.4 liter for every mole. Number of moles. Number of moles is total particles by Avogadro number. Total particle can be denoted by n naught and Avogadro number by Na. Suppose we will consider one example. 3.011 into 10 to the power 29 H2 molecules is given. We have to determine number of moles. Find mole. So number of mole is total particle by Avogadro number, that is 3.011 into 10 to the power 29 divided by 6.022 into 10 to the power 23. So this is 10 to the power 6. This is 1 by 2, that is 0.5 into 10 to the power 6. That is 5 into 10 to the power 5 moles. So the number of moles present in 3.011 into 10 to the power 29 H2 molecule is 5 into 10 to the power 5 moles. So this way we can calculate the number of moles. Now we will see total number of atoms, ions, total number of atoms, ions, molecules present in 1 mole or more than 1. So total number of atoms, mole into Avogadro number, Avogadro's, or we can write n into total number of molecules, mole into Avogadro number. Total number of ions, mole into Avogadro number. Now we will see one example. Suppose 1.5 mole K2Cr2O7 is given. We have to determine number of K atoms, number of Cr atoms, number of O atoms. This is potassium dichromate. This is potassium dichromate. This is potassium dichromate, 1.5 mole. So we have to determine the number of K atoms. If we take one molecule or one formula unit of K2Cr2O7, we will have 2 atoms of potassium, 2 atoms of chromium, and 7 atoms of oxygen. So number of K atoms, atomicity into mole into Avogadro number. So that comes out to be 2 is atomicity, mole is 1.5, and that is Avogadro number. So you will get 3 into Avogadro number, that is 3 into 6.022 into 10 to the power 23, that is equal to 1.8066 into 10 to the power 24. So the total number of potassium atoms present in 1.5 mole K2Cr2O7 is 1.8066 into 10 to the power 24. Now, atomicity of chromium is also 2, so 2 into 1.5 into Avogadro number. So this is the similar result. 3 into Avogadro number, that is 1.8066 into 10 to the power 24. Now coming to oxygen atom, we know that oxygen has 7 atoms. So 7 into 1.5 into Avogadro number. So it is 10.5 into Avogadro number. That is 10.5 into 6.022 into 10 to the power 23 atoms of oxygen. So this is our calculation. So for any substance, we can measure the number of atoms, number of ions, number of molecules, anything. So basic knowledge of mole concept is very essential for solving so many problems. Mole has wider application in other branches of chemistry also. So we must learn mole first. Suppose one question is there, 90 gram water is given. We have to find number of moles and molecules of water. So number of moles is given weight by gram molecular mass, that is 90 grams by 18 gram per liter per mole. So this comes out to be 5 moles. Number of molecules is equal to mole into Avogadro number. So it comes out to be 5 into 6.022 into 10 to the power 21. So it is 30.110 into 10 to the power 23, or it is 3.011 into 10 to the power 24. So this is the total number of molecules present in 90 gram of water. Sir? You need to fill the ink by opening the cap.